All right, this is 2018 question 2, and this is your stats sensei, Mr. Spence, an environmental science teacher at a high school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students at the school to survey. Each selected student went into the teacher's office one at a time and was asked to respond yes or no to the following question. The question was, do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question was calculated. And this was the interval. So how many students in the sample were selected by the environmental science teacher? Well, first off, I always start off by writing my confidence interval formula, which is p hat plus or minus z star p hat q hat divided by n. And I know that this part right here represents the margin of error. Okay, so that's what I stated right here. Z star, that's my margin of error. Well, I can easily go, well, if they have a 95% confidence interval, I can sit there and go, all right, I need to figure out my Z stars. So second bars, inverse norm, parenthesis 1 minus 0.95, close parenthesis, divided by 2. Mean of 0, standard deviation of 1, because we're working with a z-score, and we get 1.96. Please make it positive. So that gives us our 1.96, but the p hat, where does that come from? Well, p hat is going to always be the center. So p hat is the center of my confidence interval. That is actually my point estimate if they had asked for a point estimate. I go, okay, that's my estimate. Now, when I look at this point estimate, what I need to do is add these two values together and take the average. And when I average them, I end up getting 0.7. So that means I had a p hat of 0.7. And so I'm going to plug in 0.7 here and then 0.3 over there, or 1 minus 0.7 here. And so we're going to go ahead and solve this thing. All right. And so with that in mind, I need to pause for just a moment. Excuse me. Okay, so after I've calculated my margin of error, I mean, not my margin of error, my p hat, I still need to calculate my margin of error. And remember, the margin of error is after the part after the plus or minus. So it's basically how far we are from our point estimate. So in this case, we can take 0.7 and minus the 0.584, and we get 0.116. And that 0.7, that was, we said that that was the average of the two, minus the 0.584, and we get 0.116. Alternatively, I could have taken 0.816 and minus 0.7 and still gotten 0.116. Okay, so anyways, this is my margin of error. This is how far apart we are. So 0.116 equals 1.96, 0.7 times 0.3. So let's go ahead and start solving with this. So 0.116 divided by that. And I'm going to go ahead and square it because I have to take this radical off. Well, this is the same as saying 0.7 times 0.3. So 0.7 times 0.3 divided by, and I ended up getting 59.95. Well, we cannot have, we always round up with sample sizes. So this has been 59.1. We would have rounded up to 60. It's 59.95. We round up to 60. So the teacher sampled 60 students. All right, so things we had to have. We had to show that formula either by with new numbers in it or by formula. We had to have our point estimate of 0.7. In other words, we had to know our p hat. I assume that if we written it here, we'd be fine. Okay, because the 0.7 is there also. We needed to figure out our margin of error size, which is how far the point estimate was from either one of the endpoints, which was 0.116. We needed to calculate Z star correctly, that was 4, and then we needed to come up with the correct answer. All 5 points got you an E. If you had 3 or more of the 3 or more, you got a P. So 3 correct, 4 correct, got you a P. Otherwise, if you have all 5, you get an E. Okay, part B. Given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how bias might affect the point estimate of the proportion. So in other words, how that might have impacted the P hat, all right? So because students know that the environmental science teacher cares about the environment, they may feel pressured to respond yes, all right, in order to please the teacher, even if they don't recycle. In other words, they're saying opposite of what they do, which means they're lying. This is an example of response bias. A consequence, the sample proportion of students who claim to recycle would be higher than the actual populations of students than who actually do recycle. So how in the world do those points work? Give a reason as to why. First off, part 2 is we're starting with part 2 because it makes it easier. They're saying something opposite from the truth. All right, they said yes when in fact they don't. Why might they do that? Because their science teacher cares. In other words, they feel pressured. All right, it wasn't anonymous, something along those lines. They felt pressured because they know their science teacher cared. And it'd probably been better if I say they felt pressured because their science teacher cared. All right, and then we need to explain what would be the result. The result would be that it was higher. Okay, so if you had all 3 of those, if you had all 3 of them, you got an E. If you only had 2 of them, you got a P. Of course, that's probably not very surprising. So section 2, you had to have all 3 components to get that the E2 got you a P. So the statistics teacher at the high school was concerned about the potential bias in the survey. To obtain a potentially less biased estimate of the proportion, the statistics teacher used an alternate method for collecting student responses. A random sample of 300 students was selected. Wow, that's a big sample. And each student was given the following task, following instructions on how to respond to the question. Flip a fair coin. Please note, 50%. If heads, you must respond no, regardless of whether you would regularly recycle. So let's explore that just a moment. If you flip heads, how often would we expect that to happen? Well, 300 times 0.50, so about 150 times. If tails, respond truthfully. Now, the reason this is a good idea is because the teacher doesn't know whether or not you had a heads or whether you had a tail, so they don't know which question you're responding to. So what is the expected number of students from the sample of 300 who were required to respond no because the coin flip resulted in heads? Well, we showed our work and we said NP, so 300 times 0.5 equals 150, all right? So that's the first part. And hold on for just a second. So NP 300 times 0.5 is 150. We would expect 150 students to respond no because of the coin flip. I would expect everyone to get that part correct, but that's not even enough for a partial by itself. It's a good start, but it doesn't get us to a partial. The results of the sample shows that 213 of the 300 students responded no. That's interesting. 213. Well, 213 minus 150 equals 63. So in other words, 63 responded no because they don't recycle. 150 responded no because of the coin flip told them to, but then the other 63 responded no because they don't recycle. All right, So how many recycle? Well, if 63 don't recycle, of the 150 that had the heads, 87 do recycle. All right. So 87 out of 150 equals 0.58. So based on the sample, our estimate of the population of students who actually recycle is 0.58. If you got this part right and only this part, in other words, you didn't have this, you got a partial. If you did this and ended up working with the 63 over 150 and you put the 0.42 and you had this correct, you also got a partial. All right. So you either had both parts completely correct and got an E, this part completely right and got a P, or a combination between. Once again, this was based on 3. So EEE got you a 4, EEP got you a 3, EEI, two fully correct and an incorrect, essentially in 2 partials, an essential and 1 partial, or 3 partials got you a 2, and this got you 1. Anything else got you no points. All right. Hope this helped you a lot, and I look forward to seeing you on the next one. Thank you.